Okay, and I think we're ready to start. So, hi everyone, welcome again to my session, which is GraalVM and Microservices, the last Crusade. And I'm really happy to be here, and thank you so much for taking the time to be here with us today. So my name is Roberto. I work for Red Hat. Most of my time working in something called Cortez. Maybe you heard about that, maybe you haven't, but the session today is not going to be about Quarkus, even though I do talk about Quarkus a lot of times. I'm going to show a couple of things in Quarkus today as well, but not focuses on that specific thing for this session. Anyway, so for the agenda, so we really have, I only have here a few slides. I don't want to massacre you with a really boring presentation. If you've seen some of my presentations in the past, you know that I like to do heavy demos presentations. So I have here a few slides just to intro some of the topics and for us to have like an agreement and some overview on the state of the art. But after that, it's going to be all demos. So I hope that you'll enjoy all of that part. So we're going to look a little bit about microservices. So I'm not going to waste a lot of time over there because I guess most people already fed up and to hear about microservices in the past. But we're going to talk a little bit about GraalVM. So probably some of you already heard about GraalVM and most likely about the native image. But I want to show you some different aspects that the GraalVM brought to the table in the last few years. And then, yes, we'll go to some of the demos that I prepared for you today. Now, do you have people in the audience building microservices? So usually that's the question that I ask. And even though I don't have a room for me to see who's over there for raise of hands, I'm gonna try to just extrapolate this and maybe have like half of the room or maybe more than half of the room to raise their hands, because that's the usual numbers that I get when I ask this in a live room. So microservices become popularized in the last few years. They've been slowly being adopted. And while microservices do solve some issues, they also present some additional challenges, right? That we have to try to tackle, right? And we do have a lot of technologies to figure that out. Now, people kind of started to get fed up of all of this, right? Some people start to question that the benefits that you get from microservices are not that great, and that the challenges that they pose sometimes they're not worth the effort, especially if you're like a small company and you're starting up like a new app. Maybe you don't want to go with these kind of architectures at the first place, and maybe you're just better off doing like a plain old monolith, right? But well, maybe you want to go that route, or maybe you have like a big company you want to go that route anyway. So the goal of this session is also to try to come up with some better alternatives on if you're using these kind of architectures to integrate your code and to use GraalVM to do it. Now, while this is the main goal of the session, I mean, you can definitely use these techniques that I'm going to show to you on any kind of application. It doesn't have to be microservices one. Even though I do like to bring this up because all of these research that I did was mostly suited to these kind of architectures, right? So I'm gonna skip that. I always like to post these slides, right? So this is what usually people think about microservices these days. Maybe not all of you, but at least some of you like to think about this. And well, hopefully my goal over here is to give you like something that's going to help you with your everyday work. So yeah, everyone knows about the benefits, but let's look into some of the downsides of using microservices, right? So like people usually like to give that example of like, yeah, you have multiple teams, all of them you can just split the work between multiple teams, all of them are going to work on a different side of the app. They're going to build these autonomous services, they just going to work independently, right? And but yeah, maybe you're going to have like a big team of 200 developers and all of them like Java or some other languages. like Node or PHP or Ruby, and all of them are using the same language. But you're gonna have cases, and I came across with those plenty of times where you have teams, but all of them are going to be using like different technologies and different languages, right? So they may be mixing things like Java and Ruby or Python, and yeah, I mean that's great. People are now able to do whatever they want on the language of their choosing, but it also creates like a huge complexity when you're looking into the entire app as a whole, right? So, for instance, think about an example. Well, you need to provide configuration for your system or your application, right? So now you have to pick 3 different libraries if you're using Java, Python, and Ruby to provide configuration for those technologies, right? And most likely these libraries are not going to support the same features, right? So yeah, that may be fine because, well, the services should be autonomous and they should not, well, they should not be using things from other services. But on the other hand, it's going to be much harder for you to explain how the technology works, to actually move people around, right? Because now they're going to have to really learn how these new libraries work, how these new languages work, if they're using something like Python or they're moving to like a project with Ruby, right? So this is of course increased complexity. You have to do some research time to just make sure that all of these libraries are going to use on different languages. They're going to cover the set of features that you want to support on the entire system, right? And sometimes you may even have to rewrite some of these libraries to work for all languages. Maybe you found the perfect library in Java, but there is nothing for Python. So what you're going to do? Are you just going to write like a Python library that's going to give you all that stuff that you need, or are you going to try to pick something else? Well, we don't know. And you even have like situations where you have in-house frameworks that you may have to port or rewrite to other languages. So that's definitely a place that you don't want to be. So in the end, we need to try to find what we call the holy grail of programming languages, right? So it won't be like super cool that if you have like a way that you can actually share all of these things between different languages, right? So one of the things that we can probably look at, and I was very excited, was when GraalVM comes up, because, well, GraalVM has these polyglot features that allows you to write and run different pieces of code on the same runtime, which is, well, apparently what they promise is super great, no? So what GraalVM actually is, right? So maybe you hear about GraalVM, maybe you haven't. Most people actually heard about GraalVM because of the native image capabilities, and that's what people are most excited about these days. But GraalVM is not about native image. And even though I can show some of native image stuff in this presentation, most of the focus is going to be on the polyglot capabilities of GraalVM. So GraalVM is a universal virtual machine. It's an open source project. It's coming from Oracle. And well, you can support languages like JavaScript, Python, Ruby, R, of course, JVM languages, including not only Java, of course, but derivatives like Scala and Kotlin and Groovy, but also LLVM languages based in C and C++. So the promises from GraalVM for the polyglot capabilities seem very high. And for us to understand a little bit how GraalVM works on the polyglot side, so basically what they have done over here, right, was to introduce something that they call the truffle framework, that basically allows you to abstract the syntax trees of other languages, right? All of these are interpreted by what they call the Graal compiler, right, which interface with JAP 243, which allows you to plug in your own compiler to a JVM running environment, right? And well, of course, this is going to be, I don't want to go into much details over this because, I mean, this is not the focus on the presentation, but This is just a very high overview on how GraalVM plugs all of these things together. But yes, then the idea what you have is a JVM runtime that's able to run other languages on the same image or on the same VM, right? And if you think about it, this is quite cool, right? So what is the usual way for you to integrate multiple services or applications, right? So you usually have to go to an abstract layer or an agnostic technology layer like HTTP, right? So that's the most usual way to approach things, right? But of course, there's a cost, right? So let's just say you have like a Java service, and then you have a JavaScript service, right? So you have to call the Java service, you have to put some REST endpoints over there or some other thing that can give you like a response. You have to marshal the response, right? You have to propagate it, or you have to just send it over HTTP, and then you have to pick it up from the other side. You have to unmarshal it again, and then you can just recreate everything. So, I mean, this is not really a big deal in the sense that this is very common. So there are multiple libraries and frameworks that automate all of these for you, but this is still an expensive operation, right? So you have to just push all of this communication for an HTTP layer, right? And it's definitely not gonna be faster if you have like a direct method call in your code, right? So maybe these polyglot features can help us with some of those things. Now, why GraalVM? So GraalVM, well, aside from the native image feature, the idea is that you can use it to interoperate languages with each other, right? So in the sense that you can actually have a piece of Java code that's going to run Ruby code, or you can run JavaScript code, or you can even have the other way around, which is you have a piece of Ruby code that's going to call Java code, right? So when you start to think of the possibilities of doing this, then you can start to think of seeing like reusing libraries, right? Well, maybe you have like a Java library that you would like to use in Python or in Ruby, but it doesn't exist over there. Well, with GraalVM, you can just run your Ruby application, your Python application, and just reuse Java code directly on your Ruby code or Python code, right? That's a cool thing. Another thing is shared tooling, right? Because everything is running on the same runtime, then you can use the same tools to debug and figure out what's going on every piece and every aspect of your application or system. And you don't need different toolings to just inspect all of these different pieces from Python or Ruby or whatever other language you're using on the system, right? And a couple of other things that GraalVM does, so it does perform a lot of other optimizations in Java. So if you're running Java, it definitely is going to run Java faster than the traditional JVMs. Now, a native image, I can show this if I have some time. It does take some time to compile a native image, but the idea is that you can just create like a really close world assumption of your application, right? And this is just like a really simple command that you just type over there. And the idea is that you get like a completely binary file that you can run. When you run native image, there is no JVM anymore. So basically what you have is just a runtime and something called subtract VM that's going to run your application. And well, it's completely binary. It only contains the code that you need. So it's really cool. So that's what people are usually excited about GraalVM. But let's move into some more interesting pieces, right? So this is an example on how you can actually write or invoke a Java code from JavaScript or Node.js application, right? So yes, I'll tell you, this is not, the syntax is not the prettiest of the world, right? So, but I mean, they have to come with something, right? But in this particular piece, what you have is actually you're accessing the Java API, right? And then you're just creating like a file from the Java type, and all of this. So you look into this, it's definitely not Java. So if you look in some of the even though, well, it may look like it, but this is actually JavaScript, right? And it's just using the polyglot features of JVM to create and write Java code from JavaScript. No, there are some tricks. Well, maybe tricks not the right word, right? But the point is, for this to be able to work, you cannot use the runtimes or the native runtimes of Node, Ruby, or even Python, right? So what happens is the GraalVM runtime will come, or you have to install those packages for Node, Ruby, and even Python, and then you just have to run the ones provided by GraalVM, right? The reason for you to have to do this, right, is because, well, if you try to run Node with a JVM argument, well, that's not valid. That doesn't exist, right? But when you run Node with the JVM argument in GraalVM, well, GraalVM knows you have to start a JVM with Node, and then we'll start pull everything in the same runtime. Then you're able to have all these polyglot features available to you. But other than this, well, it will work exactly the same way. So if you have a Node application, you can still keep most of your dependencies, right? So on dependency side, there is this web page that you can look for. So most of the things are highly compatible, right? So there may be some libraries that are not supported by by GraalVM, but you can just go to this website and you can search, well, is this library compatible with GraalVM or not? And they'll let you know. But of course, most of the common libraries for all of these languages are already compatible with GraalVM. So in the end, you may be running Ruby with GraalVM, and you're not gonna see any difference if you were running Ruby standalone or the native Ruby executable. So that will be fine. Well, so now GraalVM has a couple of limitations as well, right? So not all are good things. Those especially affect things like Java, right? So if you're running native image, things like dynamic class loading, this is not supported. And those are the things that projects like Cortez and Micronaut are working on, for you to be able to have a complete Java framework that's able to get rid of all of these things that the native image supports, so it can run and build an application that's completely written in Java in native. Same thing for reflection, but again, some of these frameworks already deal with this configuration for you, so you do have to manually tell GraalVM which are the reflection calls that you need, right? The reason for this is if GraalVM will require for you to, or if you won't require this configuration, then because it doesn't know which reflection is going to be needed, then it will have to include the entire JVM and require all the class path to be in the native executable, because usually those decisions are only made on runtime, and GraalVM is not capable yet to figure out which reflection calls are going to be executed during compilation. So you need to tell that in advance. You do have to manage your own class path for integration, right? Especially when you're running those things. There's not. I mean, if you're running like small things, that's not really that difficult. If you're running bigger things, again, if you're using frameworks like Cortez, that may help. But if you're running like some standalone stuff, I mean, it's not really that hard, but there are not enough tooling yet to provide those features or those simplifications, so to say. And things like Python, I mean, the support is still on early stages. So I haven't looked. I was actually uploading the examples that I have for the demos yesterday, and I mean it works fairly well. I know that at least last year, things like NumPy for Python was not completely supported on GraalVM yet, so maybe that's changed. I know that NumPy is something that Python library developers work a lot, but it's definitely going to be there, pretty sure. And the same thing for Ruby. I mean, even though I say that, yeah, you can run Ruby applications just as fine, but as far as I know, there is no support for Rails yet. I'm not even sure if that's going to be coming on GraalVM or not. But yeah, I mean, those are some just a few limitations. No, there are a couple of other limitations, not only that I put over here because they're not just technical, right? So I mean, the amount of information has been growing over the years, but again, GraalVM is a new technology, so it's really hard to find information when something goes wrong. Of course, you can always relate to the docs, but even those they do get outdated pretty quickly because I mean, it's a new technology. They're releasing new versions every now and then. It's still, I mean, yes, you can call it stable, but still not stable at the point where, if you compare it to things like the Java runtime, where you have like 20 years of scalability, so to say, right? So there are still a lot of things on GraalVM, they're still being worked out, and new things coming out with every new version. So it's really easy to get outdated pretty quickly, right? So tooling also being improved to work with GraalVM. Of course, if you hook up like a regular debugger, it will work just as fine. Now we're starting to see some debuggers coming up for native images, and that will also help some of the things. Also, the native image support for Windows is not that great, but usually the way that you run these things is, well, everyone or most everyone, I guess, it's running Docker images. So you just build a Docker image for a Docker container, and you should be fine. Okay, so you may also ask me, well, maybe is GraalVM is production ready? I think so. My personal opinion is for JVM languages and things like JavaScript and R, definitely it is. Other languages, I mean, they may not work fully, and you have to go and check that website where you can, from GraalVM, will show you the compatibility of each library. I mean, if you're using libraries that are not over there, so yes, you're not going to be production ready. But if you're using all libraries that are supported, I think you should be fine. Corporations like Grid are already using this in production, so I think that's a good indication that, and they're already doing that since 2019, right? So 3-4 years ago, right? So I think that's a really good indication that people are happy with that. You may want to consider performance. So ideally, GraalVM will give you better performance on the runtime side. But again, you have to measure this, and of course, it's going to be dependent on your workloads and how your application is being deployed and written. So as everything with performance, just try it out and see if that actually going to help with that. Before going to demos, a couple of final thoughts about the slides, right? So I think that, and that's why I'm going to show, I think the GraalVM could potentially improve how microservices are being developed, right? Especially trying to bring some of the technologies together. You can pick whatever language you want favorite, and you can try to keep some consistency across your application, right? Maybe I'm going to show you that example, right? Maybe you have some library that you want everyone to use. So instead of having to port that library to all these languages, maybe you can just use GraalVM to run the same version of the library, and that doesn't matter which language is being written, right? Because now you have a polyglot environment where you can run that. And this is quite interesting because it kind of all removes the boundaries between languages and libraries, right? So it kind of opens up a new world for you to explore. And without any further delay, so let's go and actually look some code and hopefully show that some of the things that I've been talking about actually work, and you can see it firsthand with some demos I prepared for you. So all these demos are on this GitHub repo. They have some detailed instructions on how to install GraalVM, how to set up the examples, how to run them. So if you want to try them out, feel free to do it. If something, sometimes I may have forgotten to have some instruction here and there. So if that doesn't work, please let me know and I'll be happy to fix that. Okay, so let's get out of the slides and let's go here to my IDE. So that's the example that we have on GitHub, and I have here just a couple of these are very simple services, right? So what I have over here is what I call number API, and the number API over here has has a service, has a main method. If you look here on the imports, I'm using here a Java library to do the configuration, which is called this config provider get config. So as you can see, I'm trying to configure the port that I want to run my app. So this is actually using Spark to start an HTTP servers, and then I'm just going to, put like an endpoint over there to do something, right? But the interesting thing about this is you'll see I have this number generator generate, right? And if you look into this, right, so you'll see I'm using this polyglot context. So this is using an API from GraalVM, and I'm generating a number, but this polyglot context is actually being used to generate a number using JavaScript, right? So the way to do this is just, you have a context, you say, you create a JavaScript context like this, JS, and now I just run the JavaScript and I just got to eval on that, right? So now I'm mixing like two different languages, right? So I have Java resource, and then I have the JavaScript that's going to generate that. So that seems fairly simple. So I can go here to my terminal, and I think I have this compiled. So yes, I run this with Java jar. I have number API running that's running on port 3001, and I can say, curl, and that's on 3001, and I get a number. So yes, that's what I'm expecting. So that's fine. So I'm going to kill that. And let's look into another example over here. So now what you have is a Ruby application that's using Sinatra. So that's just an HTTP framework for Ruby. And what I'm doing now over here is, I'm generating the number now in Ruby, but I still want to use the configuration library that I have from Java, right? I want to set up the port that I had before on my Java side, right? Yes, I could definitely find a Ruby way to configure this, but of course, this was just done as an example. So in this particular case, what I have done is, I wrote this piece of, Ruby code that's actually being executed on GraalVM, and this basically what gives me the Java type, which is called the config provider. And then I can call methods on that, which I'll call get config, and then I can say, config give me the optional value of this environment variable, which is an integer, or else, and this is actually using the Java optional, right? Like it's being done on the Java code over here. It's the exact same piece. And now I can run the same piece of code now using Ruby. And as you can see on the terminal, I'm running Ruby with the JVM options. I'm passing in a class path, right? So actually, I think this is not quite right. Let me see if that works, because I actually been doing some changes there on this class path. Let me see. I think I removed that libraries, yes. Access, yes, not allowed because it's not updated anymore. I was just changing some stuff. So number API client. yeah, probably I have to change something over here. And yeah, let's do it like that. This was not supposed to be done this way, but hopefully that should work. Okay, so I just messed it up with the demos this morning and I forgot to update that jar. So probably that's not going to work. But I'm going to show you a couple of other examples with this. But the idea is that it should work. It's just that I don't have that jar anymore. I just deleted it and I cannot probably get it back. Let me just give me another example. So I'm just seeing access. Yeah. Okay, let me just try something really quick to see if I can put that demo to work. Yeah, so I need to. So pro tip for everyone, don't change your demos in the morning before the presentation because something is going to go wrong, of course. Number API jar, okay. So let me just see these one over here, client. Okay, so I think if I use this one because I changed the name, this one should probably work. That one, hopefully. Okay, let's see. Okay, so hopefully I was able to to fix that out. That's great. So now you have the Ruby version of the app running, right? And as you can see, it's running on port 5001. And well, let's call that on 5001. And there you go. You have the same number being generated. But now notice that I'm just configuring the Ruby app using the Java library, right? Which is quite cool now. So you can see now the polyglot feature of all of this. And here you have, I'm not going to run this, but in here you have the exact same example, but now using JavaScript code. So I'm gonna leave that running. And now what I'm gonna do over here is I'm gonna show you something else, which is a client. Right. So now I wrote a Java client, right? The client I want to call my number service, and the client's just going to call that. It's going to retrieve the number, and that's fine. No, but think about this for a second. I may have a client that I've written in Java, right? And now there are multiple teams that want to use that. Well, of course they can write their Ruby version or the JavaScript version, but they can also use the Java version with GraalVM, right? So if you look into the API, especially because if you look into the API of the Java side, it has already things like circuit breakers, fallbacks, retries, right? So they have a bunch of annotations for all of this. So whoever is going to write this into Ruby is going to have to make sure that all of these features are there as well. So I also have a fallback if I'm not able to reach the service, and just generate like a fallback number. Well, yeah, that's the client, right? So I can look and let's see. I'm actually gonna try to run the code first. So this is GraalPy, and I'm gonna invoke this, and now you get the number over here, right? So that actually worked. And the interesting thing over here, even though I call like a Python application, you'll see actually log that look similar to Java, what Java will output, right? Now let's look into the Py code. Now, I'm not sure if you have many Java developers around. So basically, doesn't really matter. But the client is using things like CDI and weld, right, to create some beams. And what I'm doing here on my Python code is just while I'm creating the weld instance here in the Python code directly, right, I initialize weld, and then I can just select whatever bean I have over there, and then I can just call the bean directly from Python code, right? And there you go. Now you can just, of course, write whatever Python code you want over here, and you have access to CDI beans from Weld directly on your Python code. So this is what the Python code is doing. So if you look into the Ruby version, so the Ruby version is a little bit more slimmed. And the reason for this is because I actually done, like, I create this invoker, which is Java code, which has the code that you will expect to find to initialize Weld and get the bean and call the number, right? But I did this for you to see that, well, you can pretty much do just a wrapper to call whatever Java code you want, or you can even do it just, well, it's going to take you a little longer because, well, the API or the way for you to write the Java code on the Python side, or even on the Ruby side, of course, is not spectacular in the sense that it does require some typing, but it does work whatever way you want to do this. I even got that written in C, right? So, which is really cool, right? So if you have like C developers around, you're probably going to recognize some of this. And you have a polyglot header that you can just include. Will give you the APIs to kick in the polyglot things on GraalVM, right? And if I come over here and let me just search them here because I don't know them by memory. I have a lot of stuff. Okay, and well, of course, you need to build the app first, right? So building your C, now you have a binary file that you can run over here, and well, you just run it like this, and now you have a C application that's running Weld, and well, starting up Weld, and then you can call the service around. Now, let's just look something interesting is I'm going to call the service, I'm going to kill the service, I'm going to run this again, and now you're going to realize it's taking a little bit longer. And the reason for this was, the Java side of the code kicking these circuit breaker, fallback, and retry mechanisms, right? So yes, you had some max retries with like 3 seconds each. It was not able to communicate with the service, so it kicked in the fallback, right? And that's what you get outputted over here. So the fallback. Now imagine, of course, you can probably implement all of these features in all of these other languages, but now you have this library over here that it provides all of these for you. So you can just call it directly and you don't have to worry about anything else. Okay, so another example I want to show to you is, and this is a little bit different. So this is a calculator. So this is actually run by Cortez. In one of the companies that worked before joining Red Hat, we were doing a lot of data science stuff, right? And well, usually people with data science, they like to either work with Python or R. And well, then we actually have to expose these services into the world. And well, Python and R are not like the best technologies to do all of this work. So we actually leverage Quarkus and GraalVM for writing all of these scripts in R, and then just call them directly with GraalVM. And so in this particular case, I'm going to show you the code later. So let me see, I should have it over here. So you'll see I have a curl over here that's calling calculator.add, right? And then we pass in a for with an X and a Y, which is 1 and 3. This does take a few seconds to bootstrap. But after that, then it will be fast. Of course, you can just bootstrap this at startup time and it should be fine. So there you go, you have 4. And well, you can change these numbers. Now you see it was like super fast, right? And you have a calculator. Now, what you don't realize is if you look into this calculator API, is the resources are being just exposed by regular JAX-RS, REST-DV. So probably if you've done Java, you recognize all of this. But if you look into the calculator, right? So this calculator is actually invoking functions coming from an R script, right? And if you look into the imports, this again is using the GraalVM polyglot APIs, right? So it's not only invoking the script, but it's also actually retrieving results coming from the execution of that script. So yes, a calculator is something very simple. So if you look in add, you'll see, well, we have an add function which returns an X and a Y. But this just to show you how you can actually even pass variables from the resource, right? Because you're collecting them from the form, and then you pass them to R just by executing and passing the arguments. And then you can just retrieve back the value, and you can just put it as a response to the endpoint. So this is just a way for you to actually interpret these languages in a more interesting way. So I think we only have like 3 minutes left. I still have the native image to show you, but I mean, there's already a lot of presentations that show you native image. I mean, it's not really that big of a deal these days, I believe. My main focus was to show the polyglot stuff. So I think that I will prefer to have these last 3 minutes to first of all thank you and take some questions out of the audience if they have some. So back to the studio if you have any more questions coming from the audience, and I'll be happy.